Let's read it from here. A functional interface has exactly one method. Okay, functional interface, like in other case we had multiple methods, right? Then abstract method is what? These are abstract methods. Okay, where we are not showing up all the details. These two are not. Why? Because we are showing the details. Abstraction concept is what? Hiding information, right? Tell me, out of these four, where are we hiding information?
Process
Out of these
payment.
four methods, which one are we? Where are we hiding information, guys?
Process payment and get payment
status. Yes, right. So this is what we call abstract methods, where we are only declaring and not implementing or defining it. While in these two cases, we are actually showing up implementation, right? We are showing up all the details. So functional interface is a special type of interface where it has only one abstract method. That means it can have multiple default methods, multiple static methods, but only can have only one abstract method. Okay, is it clear? How is it different from normal interface? Exactly one abstract method. Clear? So where can we use this? Like we are creating some function or operation where we only need one kind of implementation, abstract implementation. Oh, sorry, one kind of operation with multiple implementation. So, like for example, if you remember, we created a calculator program at that time, right? So in calculator, we created different different methods to calculate it. Say if we are calculating sum, we were saying 1 plus 2, right? If we are calculating subtract, we're saying 1 minus 2. Similarly, multiplication 1 into 2, right? But in one functional interface, what you can do, you can have one method which can do all the operations. Rather than having subtract, multiplication, addition, and so on, I can create one method calculate with parameters such as, let's say, parameter 1a, comma parameter 2, and then I can have different implementation. Then I can have different implementation without defining the implementation class. Because what is happening inside this? Inside this is basically when we have to do sum, we will be doing something like this, right? When we have to do multiplication, then it would be something like this. When we have to do divide, then we have to do something like this. Similarly, when we have to do subtraction, then it would be so. It's a very small operation. Am I correct? Is this necessary to create 4 different classes, implementation, and then have all this inside those? So very long process, right? If we go by normal interface, which we have done. So while we are designing a big system like a payment gateway system, payment processing system, education management system, and so on, then you could be using a blueprint, and in that blueprint you could have multiple operation, multiple abstract methods. But if you are designing a very small system, it does one operation only. That is where you could use functional interface, because in functional interface you can define, or you can extract, or you can use the declaration of method in a single line rather than creating multiple implementation classes. Any question on this? Right now I'm just giving the example, not the implementation part, but you understand when to use functional interface. The use of this is basically you're creating a very small system, very small operation, right? Like a QR code, just scan, that's it, right? Very small system. Calculator, one very small calculate system where based on 2 input you would be doing certain operation. Why you need multiple implementation classes for that? Am I correct? Any question on this? Any question, guys? Understood the situation where we need to use functional interface? Single method, very small operation, but different multiple implementations. Again, the implementation is also very small. You don't need multiple statements in that. One statement is enough. Very small. So just understand that these are used for very small system or small operation to save time, to save code. The advantage of this is you are saving time, you are saving code. Rather than writing 5 different classes and 50 different statements, you're doing that in one interface class and one statement. So the advantage of that is using less code, much better performance, and much better clarity of code. Don't have to visit different class. Yeah, somebody was saying something.
Yeah. My question is, here we are talking with regards to the interface, but when we were working on this particular calculator one, there we have created methods, right? For
but we don't need multiple methods.
Yeah.
We don't need all this, because see, all this operation is what? A single line statement.
Yeah.
So the implementation is a single line. There is one way where I can create a some IMPL, subtract IMPL, multiply IMPL, and division IMPL, right? And then interface, and then in each one I would change the function based on whatever I want to do. But the thing is, it's a very small operation. So to save code, to save time, to save classes, so this is the functionality given by Java, that if you have certain kind of operation which is very small and you only need one method, that is where you can use functional interface combined with lambda expression. Okay, combined with lambda expression, and I am coming to lambda expression now. Lambda expression is writing the function declaration method in single line. Okay,
so basically you're trying to say is the one which we did with using the methods is one approach, and this is another approach using functional interface where we can write the operation in one single line.
But this approach is better suited for very small operation, while the other approach is better suited for long operation, complex operations, and wherever you have multiple statements or multiple logic. Yeah.
So my question means, my confusion is like when to use interface and when to go with that normal process. You got my point?
Mostly you would go to the functional normal interfaces like we have done for credit card, because it would be very 1 or 2% chances that you have a very small operation or very small system to design. Mostly it would be a complex system, complex code, complex logics. Am I correct? Like for example, designing a payment gateway system or designing a payment processing system is a complex work, while calculator with just 4 operation is very small work, right? So you cannot design an entire management system, entire payment system with a functional interface, because the thing is you can only have one method, right? One method. But in that case you need multiple things. You need to check the status, you need to process the payment, you need to check the after processing, you need to check the status also, right? Whether it's processed or not. While calculator is very simple kind of program. If you get to input and just do the output. One other case was the digital, what we did, I forgot the name. What was the first assignment, guys? First or second assignment related to currency, right?
Yeah.
Currency. That is also very small. Get the currency and convert. So if I give the parameters that in which currency I want to convert and the currency which I have, again, I can change that code based on demand. So very small systems which has one operation or which can be designed in a single statement. That is where you can use interfaces. Is it clear?
Yeah. Thank you.
Like let's say for example, you want to have a list and you want to do some alternate operation on list related to sorting. Very small sorting. So that can be in functional interface. So in this case, because we have already done calculate without interface, right? If you remember, I think the first weekend we actually designed a calculator.
Yeah.
But that was a very long program, right? How many codes of lines we wrote there, right? Let's see that if we have to design certain, because that was a very small system, very small operation which takes 2 input and gives you an output. That was the whole purpose of that, right? Takes 2 input and give you an output. So something like that, takes 2 input and return a plus b. This was a very small operation, right? But we used how many lines? I think more than 20 to 30 lines. So why waste that? So with the just Java 8, it came as functional interface, lambda expression, which makes your task faster, easier. Okay, and not just that. Later on we'll see more benefits of like stream API and so on. But for now, let's concentrate on functional interface because it's related to interface which we are talking about. Very small operation, single line statements. That is where you can use functional interface, right? But whenever you have to design a complex system which involves a lot of logics, that is where you need to use normal interface. Clear? See here, I'm tagging extra attribute, right? Functional interface. So if without this, it's a normal interface. With this, it's a functional interface. The benefits are you are writing very less code. You are not writing multiple implementation classes. You're not writing long function definitions and so on. Clear, guys? Any question you can ask now. Otherwise, during writing the program, it can become complex. Clear? So let's say this was my method calculator. I will just define for now. Oh, sorry, declare for now, right? Need calculate. What is that with the data type? Then see, I'm not adding anything else. Very simple operation, very small system, right? See, if you add one more than one method, then it's not a functional interface. I cannot say something like this. It throws an error, right? Right, guys?
Yes.
Because the whole point of using functional interface is to design very small system with single operation. Clear? So the entire calculator program now will try to write as very small. So this is a single line we use, one interface. That's it. Done.
Chandan, one error regarding, not an error. When I run that previous program on the runner class, the output I'm getting null. Output is coming as expected, but I'm getting null in the console after process. Why it could be?
Yeah, show me.
One second. Why is my screen visible?
What was the last status?
6
Okay,
lakh.
status is coming as null, right?
60,000.
Show me your status payment status code. Open the payment status. No, in CC or in IMPL. Yeah, go down. I think your status is never used. Can you say in line number 13 this dot status?
Yeah.
Here also, yes.
Now shall I run?
Go down also. Here you have to say this dot status rather than that. I think you need to make similar changes in UPI.
No. Oh.
Done, guys.
Yes, Chandan.
Now in the runner class, let's go in the runner class. So now I have not created, unlike normal interfaces, I have not created any implementation class. Am I correct? Because I'll define, because it's a very small operation, so I'll define the implementation in a single line using lambda expressions. So lambda expressions are introduced in Java 8 and above, where you can design or write an implementation of an extract method in a single line set. You don't need to have a long definition. You can design and write expression in a single line statement as well. The lambda expression will be used a lot later on also when we learn about stream APIs and predicate and so on. So very important that you learn it. So for example, just let you know that how a function or lambda expression is written. For example, let's say there is a method such as this. Okay, normally this is how we define a method. Am I correct? Right, guys? This is how you write a definition of a method. Normally, right now, till now, whatever we have learned so far, guys, can you guys confirm?
Yes, sure.
We'll write the access modifier, we'll write the name, we'll write the parameters and so on. But in lambda expression, it becomes very simple. In lambda expression, you can just say when this method is called with the I and j, do what? Do operation I plus j. That's it. Okay, that's it. And you can then save the return, let's say, in sum is equal to this. This is similar to what we have written here. Is it making sense? And lambda expression is denotes like this, denoted using this symbol.
Without
Yeah.
specifying any access modifier and the
Nothing is needed.
Okay.
By default, things are actually created. So basically, if you need more settings and so on, you can have this. Otherwise, the default thing. So in this case, the default thing by default, what is the access modifier, guys? What is the default access modifier?
Public.
So whatever is the default, that is taken in lambda expression. But it makes your code more readable and more less. So basically, you're writing instead of 5 lines, 4 lines, you're writing just only 1 line. Any question on this?
If you want to define private or something, then that above statement also should be written.
No. The abstract. So this particular lambda expression only works for abstract method. And abstract methods cannot be private. Okay.
Oh.
So that is why I'm saying this lambda expression is designed only for abstract methods. Abstract methods are generally used in abstract class and or interfaces, right? In interfaces and abstract class both, what happens? The data is byte. So basically, when you saw that the functions here are not private, right?
Yes.
In interface, right? Because we need to access. I think we discussed that earlier, right? Why it needs to be public, right? Because it needs to be implemented in a different way. If you make it private, how will it that change or access or implement in a different way, right? So this lambda expression only works for public method, and because by default it is public, so that's why this statement works for public. So if you want to make it private and access it in lambda expression, that is not possible because lambda expressions only works with abstract method, and that is why it is also used in functional interface because functional interface only have abstract methods, right?
Yes.
There is a sequencing, guys. It can work for abstract methods, and abstract methods by default have what? Public visibility, right? Because it needs to have a different implementation, and since it can only work for one method at a time, so it's mostly used with functional interfaces. But if the operation is very small, you can use it for different methods also. But mostly in a single line statement or single operation with very small, very less logic, that is where you can use lambda expressions. Any question on this? So basically, whenever I write this, just understand I'm trying to write clear, and you can ignore this private part. It would be public. Okay. Also, it is not be static. It would be direct. Clear. So basically, this is equivalent to this. This particular thing is equivalent to this. Is it clear?
and then I'm not getting that any error while I declared the public interface functional demo. Like to
No,
add.
error will come if you have multiple abstract methods. In a single method, it will not come any error.
Okay, but to add the at the rate, how do I?
Oh, at the rate. You come here and say at the rate function. You can type and then it will show up. Okay.
Okay, the reason for calling this is like to use it in any other. As you mean to say.
Share your screen. Okay. On line number 2, write at the rate and type function because it's a functional interface. And now control Z. Yes. Okay. That's it. I think I already gave the code also, right?
Yes, but I was expecting that would.
Yeah.
Time me mouse
use code. Actually, I don't want to give code, but otherwise, some people are behind. Otherwise, always try to write yourself because writing will make your coding faster. Okay, typing it yourself will make your coding faster rather than copy paste.
Yes, sir.
Any question till now, guys? So now let's try to use directly. I've not implemented this functional interface. Am I correct, guys? Correct, right? So let's try. Okay. So what I will do is after all this. So let's say if I have to do an addition, so the addition can happen like this. Calculator. Tell me now what will be the value of addition, guys? What will the value of addition? Let's say if I write this statement, what will be the output?
3.
3. Why? I have said for the functional interface a comma me. So basically this functional interface only have one method, right? With this parameter, if I give wrong parameter count, it will throw an error. See, right? So it will never work for more than one operation or more than one abstract method, or even with different arguments, signatures. You need to have similar arguments like this, right? See, because I have said that see, I have not defined the calculate, right? While doing this, I have not defined the name, right? There is no name here, right? So if name is not there, and if we have more than one method name, then this will not work, right? Because then it does not know which definition. A similar thing, like if I have this thing like this, then this lambda expression will not work, right? Because it will be ambiguous for this statement to do this for which method. Am I correct? Whether it do it for calculator 1 or calculator 2, right? Guys, everybody is.
Yes, sir.
If you have any question, please do ask. So main property is like when you are writing this kind of statement, you cannot have multiple methods. Then it will be ambiguous for compiler. Since it has only one method, compiler know that whenever this signature is called, it would have to call this calculate method. Clear?